have you ever wondered how scientists study the chemical composition of distant galaxies? A question that has piqued the curiosity of many, and rightly so. There's a certain allure to the night sky, a sense of intrigue and wonder that has captivated human beings since the dawn of our species. Gazing up at the twinkling stars and the vast expanse of the cosmos, we've always found ourselves longing to understand the mysteries that lie beyond our reach. This insatiable curiosity has been the driving force behind the evolution of our technologies and techniques, propelling us from simple stargazing to the complex realm of astrophysics. From the invention of the telescope to the development of spectroscopy, our desire to decipher the universe has led us to create tools that make the invisible visible and the distant within reach. One of the most fascinating aspects of these cosmic investigations is the study of the chemical composition of galaxies. Comprehending the elements that make up a galaxy is akin to understanding its DNA. It gives us clues about its birth, its life cycle, and even its eventual demise. It allows us to piece together the story of the universe, one galaxy at a time. This is not just about understanding what galaxies are made of, it's about understanding our own origins and the grand cosmic evolution. The universe, after all, is a cosmic cauldron, a mix of elements and energy, constantly interacting, constantly evolving. The elements that make up our own bodies were once forged in the heart of stars, scattered across the cosmos during stellar explosions, and eventually coalesced to form our home planet. In essence, when we study the chemical composition of galaxies, we are not just exploring distant celestial bodies, we are exploring our own cosmic ancestry. We are tracing the path that led to our existence, and perhaps the path that will lead to our future. The journey to understand the universe starts right here on our home planet, with the curiosity and the tools we've developed. So come along as we embark on this fascinating exploration into the depths of the cosmos. So, how do we peer into the distant reaches of the universe, you ask? Well, it's all about having the right tools. And for scientists, these tools are primarily telescopes. Telescopes are our window to the universe. They're like super-powered eyes that can see light years away, capturing the faintest glimmers from distant galaxies. Over time, these tools have evolved, becoming more powerful and precise, giving us the ability to see deeper into the cosmos than ever before. There are different types of telescopes that scientists use, each designed to capture a different kind of light. Let's start with optical telescopes. These are perhaps the most familiar to us, the kind you might use to gaze at the stars from your backyard. Optical telescopes capture visible light, the same kind of light our eyes can see. But the universe isn't just visible light, is it? This is where radio and infrared telescopes come in. They capture different kinds of light that our eyes can't see, like radio waves and infrared light. Radio telescopes, for instance, can see through dust clouds in space, revealing hidden galaxies. Infrared telescopes, on the other hand, can detect heat. They're like cosmic thermometers measuring the temperature of distant stars and galaxies. Over the centuries, these telescopes have become increasingly sophisticated. Today's telescopes are not only larger and more powerful, but they're also more sensitive. They can detect fainter light and see in greater detail, allowing us to observe distant galaxies that were previously invisible. Some telescopes are even based in space, like the Hubble Space Telescope, free from the distortion of Earth's atmosphere. Each of these tools plays a crucial role in our exploration of the universe. They help us collect the light that has traveled billions of years to reach us, light that holds the secrets of the universe's past. So to answer the question, how do we peer into the distant reaches of the universe? With the right tools, of course. These tools, developed over centuries, have given us the eyes to see beyond our own world and into the cosmos. The light from these galaxies, though, is more than just a pretty sight. It's a treasure trove of information waiting to be decoded. And the key to unlocking this cosmic code? Spectroscopy. Spectroscopy is the study of how matter interacts with electromagnetic radiation, or in simpler terms, how stuff interacts with light. When light from a distant galaxy reaches us, it carries with it the tale of its journey. By studying this light, scientists can determine the galaxy's chemical composition. But how, you ask? Well, each chemical element has a unique way of interacting with light, much like each of us has a distinct voice. These unique interactions manifest as specific patterns in the light spectrum, and these patterns are akin to fingerprints. No two are the same. This is what allows scientists to identify the elements present in a galaxy. Imagine you're at a concert and the band is playing a song. You can pick out the different instruments, the strumming of the guitar, the beat of the drums, the melody of the piano, each contributing to the overall music. In the same way, scientists can pick out the different elements in a galaxy by their unique spectral notes. So, when the light of a distant galaxy reaches our telescopes, it's like receiving a cosmic symphony. By analyzing this symphony, scientists can identify the instruments, the elements, that make up the galaxy. From hydrogen and helium, the lightest and most abundant elements, to heavier ones like oxygen, carbon, and iron, each element reveals itself through its unique spectral signature. And it's not just about identifying what's there. The abundance of these elements can help us understand the galaxy's history, how it was formed, how it has evolved, and what processes are currently taking place. So, the next time you look up at the night sky, remember, the twinkling lights you see are not just distant stars. They are cosmic messages, carrying the secrets of the universe. By decoding the light from galaxies, we can uncover the secret ingredients of the universe. So, what does this information tell us about the universe? Well, decoding the chemical composition of galaxies isn't just astrophysical detective work. It's a cosmic time machine, allowing us to trace the history and evolution of the universe. Each element we find in a galaxy holds a story about the stars that birthed it. Let's take hydrogen and helium, the two most abundant elements in the universe. Their presence in large quantities in a galaxy suggests that it is relatively young and still in the early stages of star formation. On the other hand, older galaxies with the history of starbursts and deaths have a richer mix of elements, including heavier ones like carbon, nitrogen, and oxygen. And it's not just about age. The chemical composition of galaxies also sheds light on how stars form. For instance, the presence of molecular clouds rich in hydrogen and dust is a strong indicator of star-forming regions. It's within these cosmic nurseries that new stars are born, enriching the galaxy with heavier elements through the process of nuclear fusion. But our understanding doesn't stop at the level of individual galaxies. By studying the chemical composition across a range of galaxies, scientists can piece together the overall evolution of the universe. This includes how galaxies form and evolve, how they interact with each other, and even how elements necessary for life have spread across the cosmos. One of the latest discoveries in this field is the detection of phosphorus in distant galaxies. This element is crucial for life as we know it, and its detection suggests that the building blocks for life may be more common in the universe than previously thought. In conclusion, the chemical composition of galaxies is like a cosmic DNA, holding vital clues about their past, present, and future. It's a testament to the cyclical nature of the universe, where stars are born, live, and die, only to give birth to new stars and elements. Understanding the chemical composition of galaxies opens up a new dimension in our understanding of the cosmos and our place in it. In essence, our journey to the galaxies begins and ends with light. This adventure of cosmic proportions hinges on understanding the chemical composition of distant galaxies, a task that is no small feat. We've explored the tools scientists use to accomplish this, from powerful telescopes that peer into the farthest reaches of the universe to cutting-edge software that helps interpret the data. Central to this journey is spectroscopy, the science of analyzing light. It allows us to decode the stories that light carries across the vast expanse of space, revealing the elements present in distant galaxies. These insights offer us a peek into the cosmic evolution, helping us understand how galaxies formed, changed, and interacted over billions of years. As we continue to delve into this fascinating field, it's clear that every speck of light holds a universe of information. As we continue to decode the light from the cosmos, who knows what new discoveries await us in the depths of the universe?